plants use photosynthesis to absorb energy. They take the energy in from the sun, carbon dioxide, and water. From this, they produce the sugar they need to survive, plus the oxygen for every other living animal. I forgot to mention that also all energy in us and in all animals can be traced back all the way to plants. It's just, yeah. In the food cycle, everything gets what they need because the producers, and other what's known as the plants, which is the horrible green messed up thing I made, is eaten by the primary consumers, which happen to be things like birds and mice with this like amazing, beautiful mustache mouse. And then there are the secondary consumers. Darn it, I didn't get the third. The triandary consumers. I can't pronounce it either. But secondary consumers eat the primary consumers, and so they get their energy from that. And then after that, just when the tiger dies, let's just say it naturally died, it wasn't eaten by anything. The fungi and bacteria come and they break down the animal and they turn it pretty much back into the soil. In other words, also the plants can take energy from that, and so that way more mice and more birds can eat the plants, which then more tigers can eat more mice and birds, and then more fungi and bacteria can break down the secondary and triandary. I can't pronounce it. And then after that, the plants get the energy from the broken down stuff. An energy pyramid is shaped the way it is because it shows how the energy from the original source, such as corn, goes to the primary consumer, in this case the cow, which goes to the secondary consumer, which is the lion, which goes to the triandary, I can't pronounce that ever, which is sorry, I might have messed up a little bit. No, I'm right. Which is the crocodile. And after that, the times 4 consumer, which in this case is Curtis. The difference, which in this case is Curtis, because Curtis is just always that one. The difference between a food pyramid and an energy cycle is really, in an energy cycle, it shows how the energy eventually gets back to the plants, the source. In a food pyramid, it just shows how far up it can go. And yeah. I'm sorry, I really had no idea what to draw here. But for this one, it says, why is there less energy available at the higher levels of the food web? So what happens really is, when something, let's just say a cow eats, let's just say a cow eats some corn, and so he gets 10% of the energy from that corn. He gets 10% of the energy from the corn, and it goes straight to him. Now, let's just say all of a sudden a tiger jumps out of nowhere and eats the cow. Now the cow is only gonna get 1% of the energy from the corn and 10% of the energy from the cow. As you can see, if this goes more and more up, it's eventually going to get into the decimals, and it's going to be very wasteful of our resources. Because when it gets to the really high places like the quadruple consumers, I can't even it's going to eventually just end up being that they're only going to get 0.01% of the corn energy. And yeah, there really isn't that much to explain about that. To become more sustainable all the food that we use up, such as if we eat a chicken and we're only going to get like 1% of the seed that they ate, we can be more sustainable by becoming vegetarians, because therefore plants don't eat anything, so they only absorb energy from the sun, the water, and they use photosynthesis to get energy. So we get 10% of the energy from the thing that we ate. Also, I'm sorry about the horrible picture. It's just the person saying, what can we do? we can also try not to eat as much like delicate, amazing food such as like crocodiles, because they're probably going to be dry and dairy consumers. So we're going to be wasting a lot of resources at that point. So it's not going to be worth it to eat the crocodile if we could just eat something more simple, such as plants, or maybe a prime dairy consumer. If this wasn't this video was made by Aaron. Thanks to Josh.
So the higher up it is in the pyramid, it means the more corn that you're